Hello everyone, welcome to Book Project 2. This is Chao. Let's take a look at the outline today. So first we will describe the problem and give an analysis, and then I will show you guys my implementation, and third we will go through the results I got in this project. So first, let's look at this problem. This is a lunar lander problem. So the biggest feature for this problem, I think, is observation. So basically, the observation is a dimension continuous state space, which means it's practically impossible to solve by using iterative methods such as a policy iteration or value iteration over a Markovian chain. Like we learned earlier this semester, and also in this specific for this problem, we can use a PID control, but this requires the agent to know expertise in the control theory. And also, since we know the Q-learning is very good model-free strategy to solve a RL problem, and deep learning is very useful in using the neural network. So if we combine this two, it will be a newer version of the algorithm called DQN, and this algorithm has been proved to learn the 49 Atari games and beat the human players. And since the output of this problem is quite sparse, so it's DQN is probably a good candidate for solving this lunar lander problem. And for prototyping, as you can see, I just used the Keras RL problem. As you can see, just initialize the model, specify the memory and policy, and then initialize a DQN agent. Then I just run this problem a couple times. As you can see from this slides, everything. This is about the first couple iterations, and then this is about the 400 iterations, and this is about the nearly 1,000. So it's converts a lot, so it works very well. So from this prototyping, we proved this DQN algorithm works. Then all I did is just implementation this deep Q learning algorithm by the DeepMind algorithm. And let's look at my results. So this is the results I got for this episode's rewards. This depicted in this red line. And as you can see, since the process is quite random, so the rewards I got for each episode is quite varies a lot. And the blue line here is the average episodes. As you can see at the beginning, the agent is trying to learn to stop the lander from crashing, so it's under 200 minus 200, and then it learns quick a lot and hit the 200 score in around 100 episodes. So this is one the agents learn quite stable afterwards. And this is the task rewards performance over 100 episodes. As you can see, the it's a 100 random trials. Agents never crashed and always achieve a score above 50. The average is 193.89. However, the performance fluctuated a lot and had a standard of 50.05. And this is the hyperparameters I used in this project. Absolute decay, it's initialized with around 1 and then decaying to 0 at the end of the training. Because at the beginning I want to use the random, just use the random action, and at the end I want the Q. It's just select the best the action with the biggest Q value, so it's decayed a lot. And for the learning rate, at the beginning it learned a lot to stop crashing, and afterwards it just learn little by little to improve it. So that's why I use this to learning hyperparameters. So that's all for my presentation. Thank you for watching.